In this video, we are going to discuss about the channel length modulation comparison of MOSFET with the BJT. So let us see first what is channel length modulation. Actually, channel length modulation is an effect in the field effect transistor, that is, it is shortening the length of the channel which is created in between the P and the N type when there is an increase in the drain bias for a large drain biases. So this results in the increase in the current with drain biases and the reduction in the output resistance. So when we see, this is the one of the several short channel effects in the MOSFET scaling, that is, it causes more distortion in the cases of the JFET amplifiers. First, to understand this effect, we are taking the pinch off of the channel, that is, when the increase in the voltage it causes the when there is an increase in the voltage, it causes sudden breakdown, and which causes an effect in the transistor which leads to the channel length modulation. So this channel is formed by the attraction of both the carriers to the gate and the current drawn through the channel, which is nearly kept as constant, that is independent to the drain voltage in the saturation mode. Here, near the drain, the gate and the drain jointly determine the electric field pattern. When the pinch of voltage takes, there will be the possibility of drain bias occurs. So this channel is indicated by the dashed line, and when it becomes weaker, the drain is approached, leaving a gap of uninverted silicon between the end of the formed inversion layer and the drain. So you can see the pinch of voltage here. When there is an increase in the VGS, it induces to the channel which is not high. It is not high enough to induce to the channel in the case of the oxide to the drain. And as this drain voltage increases, there will not be any control in the current, so which leads to that is inverted region. That length of the region is called as the channel length modulation, and this resistance will be proportional to the length, which shortens the channel, and it will decreases the resistance in the increase in effect of the increase in the drain, which operates this MOSFET in the saturation region. And this effect is more pronounced the shorter the source to drain separation, the deeper the drain junction, and the thicker the oxide insulator. In the weak inversion region, you can see the influence of the drain of the channel and the modulation, and in that side there will be a strong decrease in the drain source, which leads to the more less than the pinch off region, that is from the less than the threshold value. So in the bipolar devices, similar increase in the current with the increase in the collector voltage is due to the narrowing effect, which we call it as the Rayleigh effect. The same thing which we can see in the channel and modulation also, that is, whenever there is a change in the length, the output resistance will be varying. Due to that, there will be increase in the drain bias. So the major factor which is affecting the output resistance is the channel length modulation becomes wider and wider, and the length is calculated as the channel length modulation. So here you can see the comparison of the MOSFET with the BJT. First, what is BJT? BJT is bipolar junction transistor. MOSFET is metal oxide semiconductor field effect transistor. BJT is a 3-terminal semiconductor device which is used for switching and amplification of signals. MOSFET is the 4-terminal semiconductor device which is used for switching applications. Types: NP and PNP. Here P channel enhancement, P channel depletion, N channel enhancement, and N channel depletion MOSFET. Terminals are collector, base, and emitter. Here the terminals are source, drain, gate, and body. When it comes to the charge carriers, in BJT, both the electrons and holes access the charge carriers. In the MOSFET, either the electrons or holes access the charge carriers, depending upon the type of the channel which is formed between the source and the drain. Polarity: BJT is the bipolar device, MOSFET is a unipolar device. In the case of controlling quantity, BJT is the current control device, MOSFET is the voltage control device. Input impedance, BJT has low input impedance, MOSFET has relatively high input impedance. Temperature coefficient, BJT has negative temperature coefficient, MOSFET has positive temperature coefficient. Switching frequency, the switching frequency of BJT is low. In the case of MOSFET, it is high. Power consumption is more in BJT and less in MOSFET. Applications, BJT can be used in amplifiers, oscillators and electronic switches. MOSFETs can be used in the high power applications. Thank you.